I just erased it, yeah. Okay, so I am trying to get x by itself. So again, this is what I just said, but I forgot to start recording it. When we look at this side, x is almost, well, it's not by itself, but there's a lot of stuff going on. It's kind of like buried between layers of things, or buried under layers of stuff. So we're going to pull those layers off one at a time. So when I say the order of things being done to x, I would say x minus 6, then squared, then multiply by -5. So we're going to undo these. So the inverse of multiplying by -5, the inverse of that is dividing by -5. So that's my first step. So now I have -9 is equal to parenthesis x minus 6 squared. So I've taken care of that -5. What's the next thing we have to get rid of? The exponent. So what undoes squared? What is the inverse of square? Square root. But hold up. This is something that you normally come to me and don't know well enough, and then we throw the pandemic on top of it. This is something that you have to start knowing right now. Anytime when you are solving an equation, if you are going to put, oh no, this is not even going to work. Hey guys, this is not going to work. Let's fix the problem. Let's fix the problem before I go any further.
We were solving a broken problem.
Oh no, I could solve it. You won't be able to solve it yet. Oh, you clearly didn't. Clearly not. You were not able to solve it yet. Okay. So I just going back real fast. I just changed the original question to have a -45 in it because otherwise it's not going to work. So that changed it when I divided a negative by a negative. It changed it to a +9, and I apologize for that. I made up the question myself, and sometimes I make mistakes. So now, going back to what I'm saying, this is important. Don't disrupt others so they miss this. When you physically put a square root in, and I'm going to put this as a different step so you can see the difference here. I'm just rewriting the same thing. When you physically put the square root in to cancel out the squared, you always have to put a plus minus. I'll tell you. When you put that square root in, you physically have to put the plus minus in there too. There's already a square root in the problem. You don't have to do anything like a plus minus. But if you are putting it in to solve, you have to put a plus minus. I can go off to the side here and say, you know, if I take -2 and square it, or if I take +2 and square it, what do you get? You get the same answer of 4. But did you know if I was originally squaring a negative or a positive, if all I gave you was 4? You don't know, so you put either. You say it could have been a 4, but it also could have been a -4, or 2. It could have been either. So we have to include both. When you multiply -2 times -2, that's a positive. Okay, so this is my next step, is I put in plus minus square root. Now, what is the square root of 9? So I now have plus minus 3 equals. When we do a square root and a squared, they are inverses, cancel each other out. So on my other side of the equation, I have just x minus 6. So my last step, I have to get x by itself. Let me erase this stuff here. My last stuff, getting x by itself, you are right. I'm going to have to add 6 to both sides. So I have x equals, I have a 6, and then I have a plus or a minus 3. Or you might have written it as plus minus 3 plus 6. Either way, it's the exact same thing. Okay. No. Because can I add 3 and 6 together? Yes. So I have 2 questions I'm answering here. So we've got two of them. We've got one that is going to be a positive 3 plus 6. And we've got a second one that's going to be a negative 3 plus 6. We've got both answers. And I thought it was Maddie who said, but that's going to be two different answers. You are correct. That's going to be two different answers. So our first x1 is 9, and our second x2 is 3. So we have two different answers that make this statement true. Let's check our answers. So I am checking in the original, but I can't zoom out far enough and have everybody see it and see the equation at the same time. So you guys might have to help me. We're doing negative 45 equals negative 5 parenthesis, and then I'm checking 3, right? And then minus 6 squared, and that was it, right? Okay. So negative 5 equals, I get negative 5 times inside negative 3 squared. So I get negative 5 times, the next thing I have to do is actually square it. So I get positive 9, which is negative 45. So that checks. So the other one, negative 45 equals negative 5 times 9 minus 6 squared. So negative 5, 9 minus 6 is 3 squared, which is 9, which is negative 45. So that one also checks. There are two answers. There are two answers. Both of them check. There are two answers. 3 and 9 both work. So I said that was a warm-up. It was a let's learn this instead. Yes, Elijah.
So what about the negative 6? So that when we were talking about with 9, or with 3 and 9. 3 minus 6. Yeah, 3 minus 6.
Hold on. Are you talking about this 6 right here, hun? Yeah. Okay. So I did 3 minus 6. Oh, and I got negative 3. I just did it a little bit on the fast side because this is not our lesson today, but apparently it needed to be. That is a lie. However, I don't know what you did when in Algebra 2, and it's very possible this was during quarantine for you.
This is.
We don't need to discuss it. I said it's very possible. Did I say geometry? I meant Algebra 2. I meant Algebra 1. Whatever you did. Whatever you did at home or didn't do. Okay, the next thing leading up to today is let's talk about x-intercepts with parabolas, with quadratics. We know that quadratics are what shape? U-shape. So we have different cases that give us different amount of x-intercepts. My first case, if I have a quadratic graph that, and I can have different quadratic graphs, guys. Let's say I have one that looks like this. How many x-intercepts will I have? I will have 2 x-intercepts. One could be here. One could be here. I will give you a different graph on the same one that also has 2 x-intercepts. Sure. How many x-intercepts?
2.
Well, let's think about if it's possible to have 3. So we could have 2 x-intercepts. I didn't think about talking about this, but let's talk about this too. What about y-intercepts?
1.
Here's 1 on the blue one. What about on the pink one? It's going to be there eventually, but it's not on my graph right now, but eventually we'll have to get wider and wider and pass through that y-axis. So one y-intercept. Well, we're not doing sideways ones.
Are we gonna do that at all?
Probably not. My next case would be one x-intercept. So to get one x-intercept, what has got to be on the line? The vertex. Very good vocabulary. If my vertex is on the x-axis, then I will have one x-intercept. And now I didn't draw them, but how many y-intercepts would I have? One. It's going to get wider and wider and wider. There's always going to be one y-intercept. And then my last case would be 0. Yeah, none. None x-intercepts. It's good vocab there. So if it opens down, but its vertex is below the x-intercept or x-axis, or if it opens up and the vertex is above the x-axis, then we would have none. We would have no x-intercepts, but we would still have one y-intercept. There's always one y-intercept for parabolas. Okay? What? Oh, somebody else had a question? Why what? No. Okay. Remember, when we want to find the y-intercept, what do we do? Besides looking at a graph, we make x equal 0. Make x equal 0. That's how we find the y-intercept. And we also solve for y. To find x-intercept or intercepts, make y equal 0. Solve for x. Do you guys need help? Because you're being disruptive. Okay, that was a quick warm-up. Now let's see what we're going to do today. Today we're going to identify the vertex, the axis of symmetry, the y-intercept, which we've already done. So that's review. But we're also going to find the x-intercepts. We're going to sketch an accurate graph. Okay? So let's look at the equation. This is review to start. Yeah.
You have to do like that one equation, find the vertex and all that, or no?
You're going to have to be more specific.
Like
Like what we did last class?
yeah.
Or two class? Like the vertex form?
Yeah.
Yes.
You have to do that, I guess.
How else are you going to find the vertex?
So I can just tell it's maybe 3.
That's what we were doing last time. That's it.
Well, you
That's it. That's it. Maybe I don't understand what you're asking. Maybe I don't. But that's what we're going to do. So Daniel has the vertex already.
You won't have to show like the equation and all that.
Like write the formula down?
Yeah.
No, I was just doing that for you guys. So Daniel has the vertex. What is the vertex for the first one? 3, 8. Very good. I'm not going to graph it yet, just in case I need to change my scale. Now we find our axis of symmetry. Allie, do you know the axis of symmetry? Okay, so I am helping her. It goes through the vertex. It goes through the vertex, so it's going to have one of these numbers. And the axis of symmetry is a vertical line that's going to go through the point 3, 8. So anytime we have a vertical line, it is an equal sign. And we just have to know if it's x equals or y equals for up and down. And if you're not sure, you say, what axis will it not cross? Because that letter's not in the equation at all. Can you tell me can you either tell me what letter I should have or what axis it doesn't cross? It doesn't cross what?
The y. Wait, no, it doesn't cross like the.
No, you were correct.
Yeah, y, okay.
It does not cross the y, so that means this has to be x. And then you look at the order of pair and you tell me what does x equal?
No,
X is the first one.
x, oh, x is 3.
Okay.